construction math. Today we're going to be able to use volume formulas, and we're going to concentrate on cylinders and spheres because that's more applicable in the construction field. So bell work. For bell work, I want you to think about a time you needed to measure something and list at least 2 on your note taker. I know this won't be hard because you're in a construction class. Teacher, pause the video, have the students share with their partners, and call on non-volunteers. Welcome back. Let's do a math check. Be sure to use these following formulas and to be sure to label your answers. So number 1, the formula for the perimeter of a rectangle is perimeter equals 2 times the length plus 2 times the width. I want you to find the perimeter of this rectangle if the length is 6 inches and the width is 4 inches. And for problem number 2, the formula for the area of a rectangle is area equals length times width. Find the area if the length is 17 feet and the width is 15 feet. Teacher, pause the video, have students work the problems, compare with their partners, have their partners double check the units, and then I'll meet you back here in a minute. Welcome back. Let's go to our slate, and we'll do the first problem. The first problem was the perimeter of a rectangle. Perimeter equals 2 times the length plus 2 times the width. So let's fill in what we know. I know from this formula that the length is 6 inches and the width is 4 inches. Remember, in order of operations, we do the multiplication first. So 2 times 6 is 12 inches. 2 times 4 is 8 inches. When I add 12 inches and 8 inches, I get 20 inches. The next formula said that the area of a rectangle is area equals length times width. In this particular problem, let's erase. Hit the eraser and see if I can erase this. Go back to my pen. And then it was 17 feet and the width was 15 feet. So I take 17 times 15 and I get 255. And then when I take feet times feet, I get square feet. And that's my answer, 255 square feet. Teacher, pause the video until students have had a chance to check or ask questions, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint and start the lesson. All right, so we checked our answers, got the same answers. So here, now I need to make sure you know your vocabulary. What's a radius and what's a diameter? All right. Pause the video and write down what you know about this. Welcome back. Let's look at let's go to our slate for a second, and let's look at a circle. All right, I'm going to draw a facsimile representation of a circle. Here's the radius. The radius is from the center of the circle, center, to the outside. Now, that's our radius. If I look at another circle, and here's the center, my diameter goes all the way through the center. So there's a radius here and a radius here. But the diameter goes from the outside of the circle through the center and to a point on the other side. So you need to know the difference between a radius and a diameter. And this side over here, so we know that diameter is equal to 2 times the radius, because we add radius plus radius and we get 2 radius. Pause the video if students are unsure or need to copy down that information. Welcome back. Let's go back to our PowerPoint, and then I'll look at the true definition. The true definition mathematically is a straight line for radius extending from the center of the circle or a sphere to the circumference or circle. The radius is half the diameter. For diameter, a straight line extending from one side of the circle to the other going through the center. The diameter of a circle is twice the radius. So for our objectives today, please fill in the missing terms. We have 4 objectives today. We're going to define terminology. We're going to list uses in construction of volume of a cylinder and a sphere. We're going to compute the volume of a cylinder and compute the volume of a sphere and see what we can do to help. So pause the video until students have filled in those 4 missing terms. Welcome back. Let's go on to our vocabulary. Volume. By definition, volume is the amount of space enclosed by an object. It's measured in cubic units or inches cubed. So fill in the picture or diagram, definition in your own words, and a meaningful sentence. We're going to do all 3 right now and then give you time to work. A cylinder. A cylinder is a solid geometric figure with straight parallel sides and either a circular or oval cross section. So either the 2 bases are either circles or ovals. They look kind of like a soda can. And the last one is a sphere. A sphere is a perfectly round geometrical object in 3-dimensional space that forms the surface of a completely round ball. So it's like a ball. So pause the video while students fill out the vocabulary squares. Have them share their meaningful sentence with their partners, and I'll meet you back here in a few minutes. Welcome back. Here are some uses I thought of in construction. Construction, you might have storage tanks that are a cylinder. You might have volume of a sphere where you have a water storage. So teacher, pause the video, have students fill in other examples of cylinders and spheres, and you can add some yourself. And I'll meet you back here in a minute. All right, so here's what we asked you to do. Find the other uses for finding volumes of cylinders and spheres. So teacher, call on other non-volunteers and add to their list. Now, volume of a cylinder, the formula. Remember when you were in geometry class that to find the general formula for any type of a volume or 3-dimensional, it's usually the base times the height. The object has, in this case, what kind of base. So you look at the base and figure out what you're going to need. So on the shape, what are the 2 bases of a cylinder? Either write this on your note taker, or if your teacher has out slates, write it on slates. Teacher, pause the video and then call on non-volunteers. Welcome back. The volume of to find the volume of a cylinder, you need to know that the bases are all circles. The top of a cylinder and the bottom is a circle. So here we go. The general formula is the base times the height. So we need to find out, do you remember what the formula for the area of a circle is? Work with your partner and see if you remember. Right. I remember that to find the area of a circle is pi r squared. All right, so write that, add that to your note taker, that the area of a circle is pi r squared. This will help us develop the formula for the volume of a cylinder. So if the area of the base is pi r squared, look how I've developed the formula. We know generally volume is base times height. So the base is pi r squared, the height is 8, so h, so there's the formula for the volume of a cylinder, pi r squared h. So let's look at an example after you've copied that down. Welcome back. Let's see. Here's an example. We have a radius of 6 inches, we have a height of 9, and we want to find out what the volume of that cylinder is. So let's go to our slate. Let's write down our formula. Volume equals pi r squared h. I'm going to fill in what I know. Pi is just a constant. Our radius is 6 inches, and I need to square that. And our height was 9 inches. So in your calculator, punch in either, if you have a pi button, use that. If you don't, you can take 3.14. So I'm going to use the pi button on my calculator. When I square 6, I get 36. When I square inches, I get square inches. And I'm going to take that times 9 inches. When I work this out, 9 times 36 is 324. I have times pi square inches. So punch that into your calculator and you should come out with approximately 1017.36 square, this time it's going to be cubic inches. because I've got inches times inches squared, or I could write it as inches to the third power. If you didn't use the pi key and you used the value 3.14, your answer will be close to this, but not exactly, and it would still be counted right. All right, so pause the video if you need to. Welcome back. Let's go back to our PowerPoint and let's check my answer. Same answer, so I did it correctly. Got inches cubed. So here's example number 2. Look at this problem and copy down any information you need to on your note taker. That the diameter is 14 feet, the height is 9 feet. And my question for you is, talk with your partner, is how is this problem different than the previous problem that we worked? Right? Teacher, pause the video, have the students share out, and then let's come back in just a minute. Welcome back. I wrote on my slate and I said the difference is this time that the radius wasn't given, the diameter was given. So I'm going to need to be very careful in this problem. So here's my formula worked out. So in this case, I took 14 feet and divided it by 2 feet to get the radius. So 14 divided by 2 is 7, and when I squared it, I got 49. You take and pause the video and take a minute or two and make sure that you came out with the same answer I did. Remember, if you use 3.14 to be pi, it's going to be close but not exact. Welcome back. Now, I want you to try these two problems. Notice number 1, the radius is 4 feet and the height is 12 feet. For number 2, the diameter is 9 feet and the height is 16 feet. Work the problems, teacher, have students compare with their partners, call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Let's go to our slate, and I'm going to fill these in. Remember again that the formula is volume is pi r squared, which is the area of the circle, times the height. So in number 1, or the first example, I have pi times 4 feet squared, and the height was 12 feet. So I'm going to do pi times, when I square 4, I get 16 square feet times 12 feet. I want to make sure so that you understand where I get this. Punch it into my calculator. I use the pi key because I got 192 pi when I squared 16 and then took it times 12 feet cubed. When I punch it in my calculator, I get 603.19 cubic feet. And again, remember that if you used pi as 3.14, it's going to be close and not exact. Number 2 is this time it said the diameter was 9 feet, so that's pi. Remember, I need radius, so that's 9/2 feet, or 4.5 feet. And I got to square that times the height, and the height is 16 feet. All right, so I get volume equals pi times 20.25 feet squared when I took 9 divided by 2, which is 4.5, and then 4.5 squared is this, times 16 feet. So I get volume equals 20.25 times 16 times 16 times pi. My answer is going to be cubic feet. Punch it in my calculator, I get 1,017.87 cubic feet. And remember, if you use pi as 3.14, your answer will be close but not exact. All right? So pause the video if students need to add these to their notes. Welcome back. Let's go back to our PowerPoint and double check. Yep, I got the same answers both times. So now, the second objective that we wanted to do is look at volume of a sphere. And here we go. The volume of a sphere is 4/3 times pi times the radius cubed. So again, in this formula, you need to have the radius. So I want to find the volume of a sphere that has a radius of 6 feet. So let's go to our slate. Let's write down our formula. Volume equals 4/3 times pi times the radius cubed. In my example, times pi, my radius was 6 feet. And I'm going to want to cube that. So in my calculator, here's how I punch it in. I put parentheses 4 divided by 3 times pi times 6 raised to the third power. I know when I cube feet, I'm going to get the final answer of cubic feet. So here, when I punch it into my calculator, I get 904.78 cubic feet. And for another repeat is that if you don't use pi as the pi key, if it is 3.14, your answer will be close, just not exact. All right, so teacher, pause the video if you need to, and I'll meet you back here in a minute. Welcome back. Let's go to our slate, let's go back to our PowerPoint as I turn my notes, and let's double check. Got the same answer. And let's move on. Now this time that it gives us the sphere has the diameter of 6 feet, and find the volume. So as you're writing that down, be thinking, can I use the diameter as it's given, or do I need to do something else for the problem? Welcome back. Let's go to our slate. And notice in our formula, the formula says the volume is 4/3 pi r cubed. So I need to know the radius. What they gave me in the problem was that the diameter was 6, and let's get the right units, it was 6 feet. So what I need to do is divide it by 2. 6 divided by 2 is 3. There we go. There's 3 feet. That's what I need to use in the problem. So my volume is 4/3 times pi times 3 feet raised to the third power. So in your calculator, push in 4 divided by 3 times pi times 3 raised to the third power. And what you have to remember here is when I cube feet, I get cubic feet. If you punch it in properly for my answer, I got 113.10 cubic feet. Again, if you use 3.14, you'll be close, not exact as my answer. All right? So let's go. Pause the video if you need to. Welcome back. Let's go back to our PowerPoint. Let's check our answer. Same answer that I got before. And now, you try this problem. You try, if the diameter is 9 inches, what's the volume of the sphere? Teacher, pause the video. Let students complete the problem, compare with their partner, and then we'll meet you back here in a minute. Welcome back. Let's go to our slate. I said that the diameter in this problem, let me write it down before I forget, was 9 inches. Here's the formula. Volume equals 4/3 pi times the radius cubed. So if the diameter is 9, 9 divided by 2 is 4.5 or 4.5. So this is what the radius is, and that's what we need to work the problem. So the volume is going to be 4/3 times pi times 4.5 inches, and that answer cubed. So I'm going to take in my calculator and type in parentheses 4 divided by 3 times pi, or 3.14, times 4.5 raised to the third power. And my answer is going to be in the units of inches cubed. When I push this into my calculator, I get the volume is 381.70 cubic inches. Did you get it right? I hope you did. Pause the video if students need to check or push this into their calculator to double check their calculations. Welcome back. Let's go back to the PowerPoint. And here we go. The answer is the same even though I did it in fraction form. And now for your closure, you have 1 minute to write down the key parts of today's lesson. Be sure to include the formulas for the volume of a cylinder and the volume of a sphere. And I'll meet you back here in another day for another construction math lesson.